Most people think top engineers are just technical geniuses. Um, Wrong. They're not smarter than you. They're not born better at math. They're not blessed with some coding gene. They just think in systems. You learn topics. They learn architectures. You memorize tools. They understand frameworks. And that difference, it's why they can switch industries, learn new languages, build startups, and outpace you in months. I'm about to show you exactly how they think. And by the end of this, you'll stop learning pieces and start learning power. Chapter 1. They learn first principles, not instructions. Most people learn by copying steps. Click here. Type this. Follow this tutorial. Feels productive. Idiot. That's dependency. If one variable changes, you're lost. Engineers ask, why does this work? What's the underlying rule? Elon Musk talks about first principles thinking constantly. Instead of reasoning by analogy, this is how it's done. They break problems down to fundamentals. Physics, logic, constraints. Richard Feynman used this approach too. If you can't explain something simply, you don't understand it. Most people stack instructions. Engineers deconstruct systems. Learning marketing. Don't memorize scripts. Understand attention incentives, psychology. Learning coding? Don't memorize syntax. Understand logic, flow, and abstraction. Once you know the principles, tools become interchangeable. Without principles, you're stuck in templates. But here's the problem though. Understanding isn't enough. Chapter 2. They build mental models, not notes. You take notes, pages of them. You highlight everything. Useless. Engineers build models. Mental representations of how things interact. Charlie Munger calls this a lattice work of models. Instead of isolated facts, they connect patterns. Supply and demand, feedback loops, compounding, incentives. When they face a new problem, they map it onto existing models. Cognitive science calls the schema formation. Schemas reduce cognitive load. Instead of processing new information from scratch, you plug it into a structure. That's speed. You face each challenge like it's brand new. They categorize instantly. Want to apply this? After learning something, ask, what model does this fit into? Is this leverage? Is this compounding? Is this constraint optimization? Build cross-domain connections. Learning accelerates when patterns repeat. But here's the thing though. Even models don't stick without friction. Chapter 3. They test themselves constantly. Most people consume information. Engineers build, reading about coding. They write code, learning a framework. They deploy something immediately. Active recall beats passive review. The book Make It Stick explains this clearly. Testing yourself strengthens memory more than rereading ever will. You watch tutorials for hours. They build prototypes in minutes. Prototype thinking changes everything. It forces clarity. You don't understand something until it breaks. When it breaks, you learn. Failure isn't embarrassment, it's debugging. Engineers love debugging. You avoid it. That's why they improve faster. Hit subscribe before you forget that. We build, not binge. But here's the brutal truth. Even testing fails if your feedback loop is slow. Chapter 4. They shorten iteration cycles. In Silicon Valley, speed of iteration beats perfection. Launch, measure, adjust. Eric Rice calls this the build, measure, learn loop. Waiting for perfect product death sentence. Engineers push minimum viable versions. Small tests, fast data. You polish endlessly, they ship early. Feedback reveals reality. Reality beats imagination. Want faster growth? Shorten your learning cycles. Instead of studying for a month, test weekly. Instead of planning for weeks, release a draft in days. Small loops compound, long loops delay. But here's the final advantage. The unfair one. Chapter 5. They automate low-level thinking. Engineers hate repetition. If they do something twice, they automate it. Scripts, templates, systems. Why? Because working memory is limited. Psychologist George Miller showed it holds about 7 items. Free that space. Use checklists. Use templates. Standardize routines. You rely on willpower. They rely on systems. Every system reduces friction. Every reduction increases focus. Focus increases output. Output increases learning. It's compounding efficiency. Now recap. They learn first principles. Build mental models. Test immediately. Shorten iteration cycles. Automate low-level decisions. You copy steps. Take endless notes. Consume passively. Polish without shipping. Rely on motivation. And then you wonder why switching careers feels impossible. It's not intelligence. It's systems thinking. But here's the problem though. Even if you learn fast, if you can't focus deeply in a distracted world, your learning stays shallow. That's why I made the next video breaking down how to build extreme focus in a world designed to destroy it. Because once you combine systems thinking with deep focus, it's almost unfair.